In the last session, we have discussed about the transportation, storage of petroleum and composition of petroleum. In the transportation of petroleum and its products, a large tonnage of petroleum and its products are transported by means of pipelines. It is the cheapest means of transportation system, and the refined products over a long distance can be transported by pipelines, or bulk of the petroleum products can be transported over sea by means of tank ships and tank cars, tank trucks and containers. These are all used for the transportation of petroleum and its products from the oil fields to refinery and from refinery to market. Right. Storage of petroleum and its products are usually done in large steel or concrete tanks. The oils which are having low flash point, just like gasoline and all, they are stored in the tanks fitted with roof which floats on the top of the oil. Thus, it avoids the space between the oil surface and the roof, and also it avoids uh, evaporation loss, fire hazards, etc. The oils which are having flash point well above the room temperature are stored in the tanks which are fitted with conical roofs, because these are safe oils. And usually oil contains all, even though it is a distilled product, they contains a small amount of moisture which actually settle at the bottom as water, which has to be taken out or drained through the drain cords. The petroleum actually composed of paraffinic hydrocarbons, naphthenic hydrocarbons, isoparaffins, olefins, naphthalenes, and aromatic hydrocarbons. Right? All crude contain all these products in the varying amount, and the composition may vary from place to place, and where the petroleum actually migrates from one place to another place during the migration, during the processing and storage, the composition of the petroleum and its products changes. Today we will discuss about the Indian resources. That is, ಇಂಡಿಯಾದಲ್ಲಿ ಎಲ್ಲೆಲ್ಲಿ ಆಯಿಲ್, ಯಾವ ಸ್ಟೇಟಲ್ಲಿ ಆಯಿಲ್ ಸಿಗುತ್ತೆ, ಪೆಟ್ರೋಲಿಯಂ ಆಯಿಲ್ ಸಿಗುತ್ತೆ, ಅದರ ಕಾಂಪೋಸಿಷನ್ನು, ಅದರ ಸಲ್ಫರ್ ಕಂಟೆಂಟು, ಇದರ ಬಗ್ಗೆ ಎಲ್ಲ ಸ್ವಲ್ಪ ತಿಳ್ಕೊಳ್ಳುವ. ದಿ ಮೇಜರ್ ಆಯಿಲ್ ಫೀಲ್ಡ್ಸ್ ಇನ್ ಇಂಡಿಯಾ ಆರ್ ಇನ್ ಅಸ್ಸಾಂ, ನಗರ್ ಕತಿಯಾ, and Gujarat, Cambay and Ankleshwar. Besides Bombay High, in producing good amount of crude oil. The Nagar Khatia crudes have a relative density of 0.857. The sulfur content is 0.17 and high wax content 7.8%, and contains very little water and salt. Characteristics of the crude shows that they are of mixed nature. The oil fields in India is mixed base crude. The crude from Assam oil fields has high aromatic content 20 to 25% of gasoline. A common feature of for Burma and other Southeast Asian crudes. The yield of straight run gasoline in above 17 to 18% of the crudes. The Assam crudes are also highly paraffinic, containing high melting waxes, but are deficient in good quality kerosene. The Cambe crude has been found to be associated with substantial amount of water, has a relative density of 0.863. Sulfur content is around 0.16% and wax content 10.6%. The oil is predominantly paraffinic in nature. The Ankaleshwar crude is light oil containing high amount of lighter and middle boiling fractions and only negligible amount of water. In this respect, it differs very much from Cambe oil through both are paraffinic based, though both are paraffinic based crudes. The crude has a relative density of 0.803, the sulfur content 0.14 and wax around 7%. Crude from Gujarat oil fields gives gasoline with small content of aromatics 3 to 5%. These are very much paraffinic and wax bearing. It produces low amount of straight run gasoline 9 to 10%. Gujarat crudes are nearer to Middle East crudes than to the Assam crudes. The sulfur content of Indian crude is low 0.15% of the total requirement of the crude in India. Only about one third is produced within the country and the rest is imported from Middle Eastern countries. That is Iraq, Iran, Saudi Arabia, Kuwait, and from Indonesia in the east. The crude from the eastern oil fields in Assam resembles those from the far eastern countries like Borneo, Indonesia, Burma in aromatics content. Middle Eastern crudes vary in relative density from 0.825 to 0.953 and the sulfur content may be as high as 4.7%. The Kuwait crude has a relative density of 0.87% and sulfur content to 2.5%. The total estimated reserve of crude in India is about 10 million tons spread over one an area of on an area of 1.04 into 10 to the power 6 kilometers square kilometers. Exploration of oil in India is done mainly by Oil and Gas Natural Gas Commission (ONGC) and Oil India Limited (OIL). Most of the refineries in India are in public sector under Hindustan Petroleum and Bharat Petroleum refineries are located at Guwahati, Assam, Barunam, Bihar, and Baroda, Gujarat, Cochin, Kerala, Mathura, UP, Vanjagan, Assam, Manali, Madras, Visakhapatnam, Andhra Pradesh, Mangalore, Karnataka, Karnal, Haryana, Digboy, Assam, Noon, Noonamati, Assam, Trombay, Bombay. Next, we will discuss about dehydration and desalting of crudes. You know that all crudes contain moisture and salt of varying degrees of water is likely to occur in an emulsion form when the crudes are naphthenic and sulfurous. ಸಲ್ಫರಸ್ ಮತ್ತು ನಾಪ್ಸನಿಕ್ ಕ್ರೂಡ್ಸ್ ಇದ್ರೆ ಅದರಲ್ಲಿ ಆಯಿಲ್ಸ್ ವಾಟರ್ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಇರ್ತದೆ. ನೋ ಹಾರ್ಮ್ ಮೇ ಬಿ ಎಕ್ಸ್ಪೆಕ್ಟೆಡ್ to the distillation column due to the presence of moisture, as there is always steam in the distillation. However, crudes have to be dehydrated to remove the salt. Water being a very good solvent for these salts, the removal is very much effective in the form of brine of the all existing salts, chlorides and calcium and magnesium distinguishes themselves in playing an invisible role in overhead corrosion. These salts in presence of steam at 150 to 200 degrees Celsius easily hydrolyze, generating hydrochloric vapors. These vapor causes corrosion to the equipment. Any crude that contains more than 5 kgs of total salt, expressed in terms of sodium chloride per 1000 barrel, may be regarded as salty crude. The general methods of dehydration of crudes are chemical treatment, gravity settling, centrifugal separation, electric desalter. At the oil field, salt is removed by settling or by adding chemicals or by combination of these two. Crudes processing emulsifying characteristics are not responsive to the settling method. These demands de-emulsification agent to increase the coherence of water droplets. Soda ash 0.5 to 5%, sodium hydroxide, salt of fatty acid 0.05 to 4%, petroleum sulfonates are such chemicals which hastens or fastens the agglomeration of water droplets. A good amount of water should be available in crudes for such treatment. Lack of water demands fresh addition of water to an extent of 20%. After adding chemicals and water to the desired extent, the crude mixture is allowed to stand at 75 to 80 degrees Celsius at a pressure of 15 kg per centimeter square for a long time in a large, tall tank. The pressure ensures the retention of volatiles in the crudes of required. A small amount of de-emulsifying agent are added. A good separation of hydrocarbon, sand, aqueous phase results when the crude is allowed to stand for 48 hours. The settling techniques are not effective and time consuming. Continuous operations is not possible, with the result of large amount of space and equipments are to be isolated for the purpose of treatment. Similarly, centrifugal separation is not also economical due to the huge energy requirement and less quantity handled. Hence, all these gave the way to electric desalting. Electric desalting, this is the schematic flow sheet of electric desalter. Here, crude and water are actually preheated in a heat exchanger and fed to a desalting unit where electrodes are actually provided, and here a transformer is there to supply the high voltage through the electrodes, and which actually breaks the emulsion, and salt present in the oil actually dissolves in the water after breaking the emulsion and settles at the bottom as rain solution which can be discarded. Let us see the process here. Simultaneous desalting and dehydration is achieved in this unit with a spectacular removal of more than 90% of salt just less than a half an hour. The principle in this separation is very simple. A potential of 20,000 to 24,000 volt is applied between the electrodes through which crude is passed. Water present in the form of emulsion agglomerates all the salts to the bottom as the drain, while the crude flows at the top and forms an separate layer. The temperature in the electric desalting is maintained about 90 degrees Celsius and the pressure 5 to 6 kg per centimeter square. The power requirement is less, usually 0.01 kilowatt hour per barrel of crude. So this is how petroleum is desalt and dehydrated in electric desalting unit. Let us see some of the MCQs in this session. Question number 1. The major oil fields in India are in dash states. Options are A. Assam, B. Gujarat, C. Rajasthan, D. Bihar. Right answer is answer A. Assam. Question number 2. Indian crude oil contains sulfur around dash. Options are 0.4142 to 0.15%, option B 0.16 to 0.18%, option C 0.17 to 0.19%, and option D 0.2 to 0.24%. Right option is option A 0.14 to 0.15%. Question number 3. Salty crude contains dash kgs of total salt per 1000 barrels. Option A 4, option B 5, option C 6, option D 8. Right answer is option B, that is 5 kgs of salt. Question number 4. The voltage maintained in electric desalter in the range of dash. Option A 15,000 to 18,000. Option B 20 to 24,000. Option C 22 to 24,000. Option D 24 to 26,000. Option B is the right answer, 20 to 24,000. Question number 5. The pressure and temperature in electric desalter is dash. Option A 5 to 6 kg per centimeter square, 90 degrees Celsius. Option B 5 to 6 kg per centimeter square, 80 degrees Celsius. Option C is 6 to 8 kg per centimeter square, 90 degrees Celsius. Option D 6 to 8 kg per centimeter square, pressure and 100 degrees Celsius. Option A is the right answer. Right. Thank you.